Now let's look at problem 11. Problem 11. Hey, the probability of an event A is given by P of A is a number between. Now, there are three basic axioms of probability, and one of them is that the probability of an event is between 0 and 1. The probability of an event is between 0 and 1. So, the answer here is just C. The probability of any event is either the probability 0 or, between 0 and 1, or maybe 1 over 2, 1 over 4, 1 over 8, or 1 over 16, or 1, right? So this is just basically definition of probability of an event. Okay, now let's look at this, this problem. We want to simplify this rational expression, and how can we do this? So using the law of indices, right? A to the power of m plus n is the same thing as a to the power of m times a to the power of n, right? So using that law, this is going to be 3 to the power of n dot 3 to the power of 3 minus 3 to the power of n dot 3 to the power of 2 divided by 3 to the power of n dot 3 to the power of 1, which is just 3, minus 3 to the power of n. Now, if you observe that 3 to the power of n is both common to each of the term in the denominator and in the numerator. So what I can do is I can factor out 3 to the power of n from the numerator. So I'll be left with 3 to the power of 3 minus 3 to the power of 2 here. And I can also factor 3 to the power of n in the denominator. I'm just going to be left with 3 minus 1, right? So this 3 to the power of 3 can cancel this one, and I'm going to be left with 3 to the power of 3 is 3 times 3 times 3, and that's 27, minus 3 to the power of 2 is 3 times 3, and that's 9, divided by 3 minus 2 is 3 minus 1 is 2. So 27 minus 9, that's 18. That's 18 divided by 2, and this is 9, right? 18 divided by 2 is 9. So my answer here is B, 9. Okay, I hope this helps. In how many ways can the letters of the word Nwafo be permuted? So basically, what you want to do, since these are distinct letters, right? N, W, A, F, O, R. Basically, it's just, you just count the number of letters there. 1, 2, 3, 4, 5, 6. So this is just going to be 6 factorial. And what is 6 factorial? This is going to be 6 times 5 times 4 times 3 times 2. And you just multiply the 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. And 360 times 2 is what? Is 720. 720 times 1 is what? Is 720. So the answer here is just C. Okay? Find the remainder when this expression is divided by x. So what I want to do is I want to do a long division. X to the power of 4 minus 11x plus 2x, right? So x to the power of x divided by x to the power of 4 is x to the power of 3. So this x to the power of 3 times x is going to be x to the power of 3. X to the power of 4, right? So I'm going to subtract. So x to the power of 4 minus x to the power of 4 is 0. So I'm going to just bring down, the negative 11x and plus 2. So I have negative 11x plus 2. So since this part is 0, I can remove that 0 there, right? So x divided by, the next thing I want to do is that this x here divided by this term here, right? So this is just going to be negative 11, right? Negative 11. So negative 11 times x is just going to be what? It's going to be negative 11x. So I have negative 11x, right? So I'm going to subtract. If you subtract negative 11, negative 11x, this part is going to be, this part is going to be 0. Then I bring down my 2. So the remainder there is just 2, right? So the remainder here is just A. 2. Okay, I hope this helps. Now let's look at problem number 15. So how can we find the value of k here? Now we see this, roots, floating all over. What can we do? One of the things we can do is we'll just want to get rid of the roots here, right? So what I can do is I can multiply both sides by square root of 2. So what I'm going to do is I'm going to multiply both sides by square root of 2. So 5 divided by 2 square root of 2 minus square root of 8 equals square root of 2k square root of 2. So just multiply both sides by square root of 2, right? So if you multiply each term here, so you have square root of 2 times 5, 2 square root of 2 minus square root of 2 times square root of 8 equals k square root of 2 times square root of 2. Remember the rule of saw that says the square root of a times square root of b is equal to square root of a times b, right? So I'm going to apply this rule here, right? So first of all, I can divide this square root of 2 here and this square root of 2 here, right? So I'm going to be left with 5 over 2 minus square root of 16 equals k square root of 4. Square root of 16 is what? Is 4. So I have 5 over 2 minus 4 equals k. Square root of 4 is 2, right? So this is just going to be, so I can rewrite my 4 as 8 over 2, right? Because I want both of them to have the same denominator, right? So this is going to be 5 minus, so this is going to be 5 minus 8 divided by 2 equals 2k, right? And then this is going to be negative 3 divided by 2 equals 2k. And I can divide both sides by 2. You divide both sides by 2, you get negative 3 over 4. And your k is that. So negative 3 over 4, that's C. Okay. 16. We want to differentiate that expression with respect to x. So before we do this, I want you to know that the derivative of a constant is always 0. And if you have sine, for example, if you have sine bx, the derivative of this is just going to be you differentiate what is inside, right? This is the bx, sorry. Differentiate this bx that is inside. You differentiate bx with respect to x. You differentiate that, you get b. Then differentiate sine, you get what? Cos, right? Then you have your bx back. So this is just something I want you to note as we solve this problem. So I want to differentiate this. Derivative of 2 is a constant. That's going to be what? 0 minus, the next thing is that I want to differentiate what is inside here, which is 2 negative ax. So the derivative of 2 is what? Is 0. And the derivative of negative ax is going to be what? Is going to be negative a. So I have negative a. So I have that there. Now the derivative of sine is what? Is cos. So I have cos. Then I'll just write what I have inside the back. Right? And this is just, if you simplify, this is just going to be a cos 2 minus ax. And that's it. So that's A. Oh, we are making good progress. Now we want to evaluate this, want to evaluate this expression here, right? So what we want to do is that we want to rewrite 1 over 25 in in an exponent, is in an exponent form, right? So I have, this is going to be 25 to the power of negative 1 to the power of negative 1 over 2 plus 8 to the power of negative 1 to the power of negative 2 over 3. And this is going to be, so this is going to be 25 to the power of, so this power here and this power here, they can multiply. Similarly, this power here and this power here, they can multiply, right? So I'm going to have 1 over 2 plus 8 over 2 over 3, right? 8 to the power of 2 over 3. So I can rewrite 25 as 5 square, right? 1 over 2, and I can rewrite it as what? 2 to the power of 3, 2 over 3, right? So now this 2 here, because this is like 2 over 1, right? This 2 here can cancel this 2 here. And this is like 3 over 1. This 3 here can cancel this 3 here. So I'm going to be left with what? I'm going to be left with 5 plus 2 to the power of 2, right? And this 5 plus 4, this is equal to 9. My answer is just C. Okay, we are making good progress. Now, want to find alpha minus beta, right? And those are the roots. Those are the root of the equation. So if you have an equation like this, one thing you want to do is that you want to see if you can simplify it further, right? Without changing the problem. So for this now, I can just divide through by 3, right? Because 3 is a common factor. So I can divide through by 3. If I divide through by 3, 3 divided by 18 is going to be 6 plus 3 divided by 15 is 5x, 5, then I have the x, then minus x squared equals 0. So to make things in a familiar form, I can just move everything to the right hand side. So I have x squared minus 5x minus 6 is equal to 0, right? Now, you want to factor this quadratic equation, right? I mean, this expression, you want to factor this expression here, right? And now you want to look at what are the two numbers that when I multiply them, they give me negative 6. They give me this part here, right? But when I add them, they give me negative 5, right? What are those two numbers? So if I have 6 and 1, 6 and 1, if I multiply them, they're going to give me 6, right? But I want negative 6. But I also want them to add to give negative 5. So I have to put the negative here. So I have negative 6. If I multiply them, I have negative 6. But if I add this, negative 6 plus 1, I get what? Negative 5, right? So I'm just going to have x, x negative 6, x plus 1. This is just going to be 0, right? So if you have x negative 6 is equal to 0, or x plus 1 is equal to 0. So I have x is equal to 6, or x is equal to negative 1. So since these are the roots of this, so I'm going to just call one of them alpha, the other beta. So I'm just going to call alpha is equal to 6 and beta is equal to negative 1. So remember, I want to find, what I want to find is alpha. I want to find alpha beta minus alpha plus minus beta. So what is alpha beta? Alpha beta is what? Is 6 times negative 1, which is just negative 6. So alpha minus beta is just going to be negative 6 minus, what is my alpha? My alpha is 6. My alpha is 6. Then I have my beta is what? Negative 1. So I don't know why I keep writing alpha is 6. So this is just going to be negative 12 plus 1. This is going to be negative 11. And the answer there is just B. Okay. Number 19, we want to integrate this function. So I have the integral of 1 minus 2x dx, right? So basically, the integral of, so this is just, the integral of a constant is usually x, right? And how do I get x? How do I get x? So I can write that constant. Let me just explain this. I can write this 1 is the same thing as x to the power of 0, right? So I can write x to the power of 0 minus 2x dx, right? So I'm using the power rule, right? The power rule says the integral of x to the power of m dx is what? Is x to the power of m plus 1 divided by m plus 1, right? So integral of x to the power of 0 is going to be 0 plus 1 divided by 0 plus 1 minus 2 1 plus 1 divided by 1 plus 1 plus the constant of integration. So this is just going to be 1 divided by 1 plus 2, 2 divided by 2 plus k. If you simplify, you get x minus x squared k, right? Because this 2 here we cancel this 2 here. And x to the power of 1 is just x. So the solution here is just is A. Okay, you're making good progress, right? Now this last problem, we want to find this, right? This is a binary operation problem. So they defined A operates B as 2A minus 1. So if you want to find 3 operates into bracket 2 operates 1, so what we want to do first is that deal with, remember the rule of BODMAS or PEDMAS, you want to deal with what is inside the bracket first, right? So deal with the 2 operates 1 first, right? So deal with the 2 operates 1 first. So what I'm going to do is I'm going to write A operates B. A operates B, what is given is 2A minus 1. So if you compare these parts, right, if you compare these, right, my A is going to be 2 and my B is going to be what? It's going to be 1, right? So this is just going to be 2. What is my A? My A is 2 minus 1. So this is going to be 4 minus 1 is 3. So that means 2 operates 1 is going to be 3, right? So, but I want to simplify. This is my goal. I want to simplify 3 operates all that. So I have 3 operates 3, right? How am I getting 3? Because 2 operates 1 is already 3, right? So 3 operates 3. So I'm not going to do it. What I'm going to do is I'm going to write A operates B. How is it defined? It's defined as 2A minus 1. So what I'm going to do is I'm going to compare this. So my A is 3 and my B is also 3, right? So this is just going to be 2. What's my A? My A is 3 minus 1. So this is going to be 6 minus 1. And this is 5. So the solution is 5. Wow, we did it. We did it. Wow. I hope this helps you. Please, if you have not subscribed, kindly subscribe to this channel to get to get notified when I post more helpful content. Wow, I wish you the very best in your post JAMB, in your post UTME. Thank you.